Hello, my name is Anthony Rivera, and this is Chemistry Chapter 5 Problem Sets for Chem 10, Professor Wynn's class. Let's get started. There are two samples, 100 grams of iron and 100 grams of wood. Both are the same starting temperature and are placed in an oven. After a short period of time, they are taken out, and you notice that the wood is cooler to the touch than the iron is. What can you say about the relative specific heat of the two samples? So to answer the first part of the question, I want you to think about this slide on a sunny day. When the sun comes out, it doesn't take long for the slide to get hot. That's because the aluminum doesn't have much of a heat capacity, so it gets hotter faster. In the same sense for the question that was asked earlier, the iron doesn't take that much time for it to get hot. So that being said, when you put it in the oven, the temperature will rise quite faster than the wood. That's not quite the same as it is for wood. Wood is actually has a higher heat capacity versus metal. Because of that change of heat capacity, it actually takes longer for the wood to change temperature like the way the metal did. That being said, if you put them both in the oven together, obviously the metal would change temperature faster than the wood. And that's because one had a lower heat capacity and the other one had the higher heat capacity. A bottle containing 591 grams of water at 4 degrees Celsius is removed from the refrigerator. How many kilojoules are absorbed to warm the water to room temperature at 25 degrees Celsius? So, what you want to do first is you want to circle all the things that are relevant. So 590 grams, 4 degrees Celsius, 25 degrees Celsius. Then you kind of want to write them down. So that way you know what you're working with. So first, 591 grams of water. You need to that times by what? You gotta know what it is. So if you don't know what it is, you might want to look at your notes. I will put it in a second, but right now we gotta find out the difference between the degrees. So 25 subtracted by 4 equals 21, right? So 591 grams times what? Times 21 degrees Celsius. So we need a conversion factor in the middle for us to get our problem. So let's go ahead and erase that. Alright, so if you don't know, I'll be writing it right now. So it's going to be 4.184 joules over grams degrees Celsius. Now what does that do? That crosses out the grams on one side and degrees Celsius on the other side. And so I forgot to write the degrees Celsius, so let me go ahead and write that. Okay, so now let's go ahead and cross them out. Change colors. Here we go. Those are crossed out. And then what are you going to do? So now that you already have your conversion factors, I'm pretty sure you should be used to this by now. You want to just multiply across. So when you multiply across, it's going to be 591, without the grams now, times 4.184 joules times 21, right? And you will get 51,927.6 joules. But are we done? Actually, no, we're not done. So, what's the next step? We got to multiply it by 1 kilojoules, right? Because we actually have to find the kilojoules, not just the joules. So, there are 1,000 joules in 1 kilojoule. So that will equal 51.92. But not done yet, right? Because we have, what, 2 sig figs. So we want to go ahead and round that up to 52 kilojoules. Alright, on to the next one. Okay, so number 3, you have 10.0 grams of liquid H2O and 0 degrees Celsius. So go ahead and start circling what you need to do. How much energy is released / absorbed for the sample to freeze? Was heat released or absorbed by the H2O in the process? So accident. So, like I said, circle what is relevant to your problem. That's always a good habit, so that way you know what is going on. So, I think it's a little frozen. Okay, so you need to find Q. Q is your heat, right? What's the next thing we're looking for is MHF, heat of fusion. So that's pretty much mass times heat of fusion. So let's go ahead and enter that in. 10 grams, which is your mass. And then what's the heat of fusion? It's going to be 334 joules over grams. And if you don't know that, that's also in your notes. So you take out the grams. 10 times 334 equals what? If you don't know, put it in your calculator. But right here we got 3,340 joules. Now what's next? So we want to turn that into what? Kilojoules. So there's 1,000. Kilo is 1,000. So 1,000 joules and 1 kilojoules. I think I put grams on accident, but that's okay. You get the message. 3.34 kilojoules. And that's going to be released. So basically what's going on here is that you have to read the question. So look at it again. If you didn't catch it, the hint is there. It says for the sample to freeze. So what's going on? Basically you're changing phase. You're going from liquid to solid. So basically it's got to release energy. So number 4. Draw a heating or cooling curve for each problem. Then, using the values for the heat of fusion, specific heat of water, and or heat of vaporation, calculate the amount of heat energy in the following. So basically, you got to know which problems you're working with and which formulas you're going to need. So calories released when 75 grams of steam at 100 degrees Celsius condenses, then cools to a liquid of 15 degrees Celsius. So what problem are you working with? You got to ask yourself that question. If you don't ask yourself that question, then you're not going to know the answer to what you're supposed to do. So, what do we do? Well, first you got to circle the stuff that you're working with. So 75 grams, 100 degrees Celsius, then we have 15 degrees Celsius right there, right? So that's a change in temperature, so you already know how you're going to draw your heating curve. After drawing your heating curve, it gives you an idea of what you're working with. So heat's on the bottom, temperature is going to be on the side. We already know what we have, which was given. So we're going from 0 all the way up to 100 degrees, right? So you go ahead and put your 0, count all the way up to 100. So what I did was I went 10, 20, 30, 40, 50, 60, 70, all the way up to 100. And then I labeled it as 100 on the very, very top. And so what you do with a heating curve is, the way you draw it, is you're going to just pretty much start from where it said 100 degrees, which was your starting point, and then go all the way down to 15 degrees, right? Because that's what the problem said to do. So let's go ahead and do that. So it was the same right here, and then it goes all the way down to 15 degrees Celsius. So what's next? Yes, you have your heat 1 and your heat 2. If you saw that on your own, then good. Heat is equal to Q. So that's how you know if you're doing it correctly. So what we do next is we have to write down the formula, which is Q1 is equal to M times heat of vaporation. Why did I write that? It's because the substance is vaporizing. So 75 grams times 2,260 joules over 1 gram. So over that 1 gram, once you calculate your calculations, it's going to be 169,500 joules. Are we done? No, not quite yet. So I'm going to draw this line in the middle because what? We're missing still the Q2. Q2, we're going to use the formula MCAT, which is mass and change of temperature, right? Let's go ahead and put that in. 75 grams, and our change of temperature is going to be 4.184 joules over grams degrees Celsius times what? 85 degrees Celsius. And how did we get that? 100 subtracted by 15 actually equals 85. So that's how we get that. If you didn't know how to do that, well, now you know. Alright, so what we're going to do is we're going to cross out the similars, right? There you go. Now we're just going to be multiplying across. Multiplying across, we'll get, let's see, we should get 26,673 joules. Okay, so what's next? That's not it, right? So you have Q1 plus Q2 gives you your answer. So how do we do that? Well, we have the answer right there. Q1 is equal to 169,500, and Q2 was 26,673. So let's go ahead and write those down and add them together. Now when you add them together, that gives you your answer, right? So our answer is going to be, waiting for you to put it in your calculator so you can do the math yourself. It should be 197,000, right? But what else can we do? If you wanted to, you can do other things. Oh, I'm sorry. Actually, 196, 173. If you caught that, then you're doing something right. If you didn't catch that, it's probably not, you're not putting in the calculator correct. So the total answer will be rounded up 20,000 joules. But if you want to write it differently, you could put 2.0 times 10 to the 5th power joules. And that could be your answer right there. Alright, there you go. But let's see. What if the question asked you a different way? What if it wanted you to find it in calories? Well, that's not a problem at all. You just got to know what you're working with and the formula. So let's go ahead and erase everything right here. And I'll go ahead and show you how to do that in calories as well. Might help you out. So pretty much you have the same stuff. You just got to put it in a different format. So in calories, what do? You got to use the same formula, right? So that's going to be the MHV, right? So Q1 will equal to 75 grams times 540 calories in what? 1 gram, right? Because we had to cross out that gram. And we get, when we do our calculations, 75 times 540 will equal to 40,500. We're not done, of course, because we still need to find Q2. Q2 will be 75 grams times 1.00 calories in grams degrees calories. I'm sorry, Celsius, times 85 degrees Celsius. And if you didn't know how to find 85 degrees Celsius, just rewind and go back to the first part and I'll show you how to do that again. So, cross out the similars, multiply across, and we're going to get 6,375 calories. Are we done? If you said no, you're on the right path. So we have Q1 plus Q2 equals what? So get your answer for Q1, get your answer for Q2. Go ahead and add those together, and what will you get? If you did it correctly in your calculator, or if you're a good mathematician in your brain, should get 46,880. But you always gotta ask yourself, how many sig figs am I working with? So you already know the answer. 47,000 calories, and are what? They are released. Go ahead and put calories released. So for B, calories needed to melt 3.79 kilograms ice sculpture at 0 degrees Celsius into a liquid state that eventually is 15 degrees Celsius. So ask yourself, what's going on here? The question is asking us what is going to happen when this sculpture starts to melt. So we should already know that heat is being absorbed to do what? To make that sculpture melt into water. So circle everything that you need like I just did. My heat curve is going to start at 15 degrees Celsius at the highest point, 0 degrees at the lowest. So what's going on again? Ice melts, right? But where does it start at? 0 degrees Celsius, because it told us, right? So we're going to go up in temperature. So our first heat was when it was at 0 degrees, and then when it changed, it was 15 degrees Celsius, right? So we're going to put Q1 heat times heat of fusion again, and pretty much, if you don't know, it's going to be under the heat of fusion right around state changes in your notes. So if you don't know, just go back to your notes, check it out. And first, what we got to do is 3.79 kilograms. We can't work with kilograms, unfortunately, with this, the formula that has been given to us. So what we're going to do is we got to convert it to grams. I have two ways to do that. So let me show you the first way that I learned in Professor Wynn's class. 3.79 kilograms times 1,000 grams over, yes, 1 kilogram, right? And that will cross out. And you just multiply it by 1,000 and you'll get your grams per 3.79 kilograms. Now here's the other way I've learned. So you put 4 lines, put a period, put another set of lines. It should be 6, but I didn't put it right here. K is kilo, gram, liter, meter, decimeter, centimeter, millimeter, and you add a couple more, and you will get your micros. So that U stands for micros, right? So all you gotta do is put your 3.79. So the first number is gonna start at the K, because we're in kilograms. You put 379, right? So it's kilograms. Let's go ahead and put that 3 where the K is at. 379, right? So how do we complete it? Well, we got to go to grams, so put a 0 there. And our decimal was where? Right next to the 3. So we're going to carry that over. And there you go. 3,790 kilograms. I'm sorry, grams. Right? So then I'm going to go ahead and write this answer down. Alright, let me erase everything. Hopefully that helps. If you're not good with converting or using the conversion factors, at least you can get an idea how to help yourself move faster, especially when it comes to tests. So there's 80 degree calories in a gram, right? If you don't know that, refer to your notes again, because they're in there, believe me, they are there. So 303,200 calories, right? And that's the first part. Now we need Q2. Q2 is MCAT. Hopefully you know what that stands for already. So what do? Put our 3,790 grams, what we converted earlier from kilograms, times 1 calorie, grams in degrees Celsius. And we have our change in temperature, so a change in temperature is going to be 15 degrees Celsius, right? As before, you multiply across and eliminate what's the same. So grams and grams cancel out, degrees Celsius cancel out. We get 56,850 calories. And yet, we are still not done, right? We are still not done. We use those two Q1 and Q2 to add them together to get our final answer. And unfortunately, that's all the time I have. However, I'm sure you got the correct answer. So, sorry, not sorry. Hopefully you're doing good, and hopefully this video has helped you a lot. Have a nice day.